In this next section, I want to explain to you what we can do with biogas. There are several options. As I mentioned, we make an energy-rich gas. If you just take methane, natural gas, it has an energy content of about 10 kilowatt hours per cubic meter. And if we take a kilogram of organics, we generate about 0.35 cubic meters of that biogas, which means that we will make about 3.5 kilowatt hour of energy in this gas per kilogram of organics that we convert. So how can we harvest this energy? Well, you can just burn the biogas in a boiler. And that will give you a lot of heat. About 85% of that heat can be recovered, and about 15% is typically a loss. This is very useful, for example, if you're at a brewery. You want to make beer, you have to heat up the water for the brewing process, so you need a lot of heat. If you're large enough, you can go a step further and you can burn the biogas in a so-called combined heat and power. This is a turbine that is going to make electricity. About 35% of that energy that was in the biogas is becoming electricity. 50% of this is becoming heat, and the rest is typically lost. Finally, biogas as a mixture of methane, CO2 and other gases can be split via different means. And then we generate a stream of pure methane, biomethane. This is the same as natural gas, so it can be injected into the local gas grid, or it can be used as a fuel for cars. A good way of looking what we can do with biogas is to consider a wastewater treatment. I just mentioned a brewery. Breweries are often going to use an anaerobic digester. They have a choice. They can treat their wastewater quite conventionally in an aerobic process, which means that the carbon coming in from the brewing is with oxygen turned into CO2. About 40% of the CO2 comes out. About half of the carbon ends up in sludge, which is harvested, and some 5% remains. The alternative is to turn the aerobic treatment into an anaerobic digestion process. And then of that carbon, about 76% of the carbon ends up in CO2 or methane, about 4% in sludge, so they don't really make much sludge here, and about 20% of the carbon remains in the wastewater, so it doesn't treat as far. So if we consider now a comparison between an aerobic and an anaerobic process, well, the anaerobic process produces biogas, biogas produces electricity. So overall I get about net 1.4 kilowatt hour per kilogram organics converted as electricity. While in an aerobic process I have to blow in oxygen, so I spend half a kilowatt hour to remove that kilogram of organics. Aerobically, I also make a lot of sludge, about half the COD ends up there, while in anaerobic conditions about 5% of the COD ends up in the sludge. The aerobic process works at ambient temperature. For the anaerobic process, I typically need a somewhat higher temperature. So I'm going to use some of the heat of, for example, burning a biogas to heat up the reactor so it works fast enough. An advantage of an aerobic process is that it does remove nutrients like nitrogen and phosphorus, while anaerobic processes don't. And finally, in terms of rate, the anaerobic process is very fast, very intensive, more than 10 kilograms of organics removed typically per cubic meter of reactor per day, while an aerobic process runs around 1, maybe 2 kilograms of organics. So if you look at this, each process has its advantages and disadvantages. So if I'm a brewery, I have a wastewater with a lot of organics in there, I will first take an anaerobic process to remove as much as possible, recover energy, recover heat, because I need that and I will not make a lot of sludge. And then the rest I can post-treat it in an aerobic process. So in this final overview, I want to give you a feeling of what we do in practice with the biogas. So in Europe, at this moment, the European Union produces about 186 terawatt hours worth of energy with biogas. That's about 7% of renewable energy. About 31% of that goes to electricity. About 4% of the heat generated can be sold for different applications, and about 16% of the heat is consumed on site, for example, for the brewery. 7% of the biogas is already turned into biomethane and injected into a natural gas grid. And 42% today is unfortunately lost energy.